Hi, 8th graders. Starting out again 1.98, relations and functions. Um, this one I don't think you guys will find extremely hard, but we'll see. Determine whether a relationship given as an equation, a table, variable, or graph is a function. Apply the vertical line test to determine whether a graph represents a function. Graph related data on a scatter plot and draw the and interpret its best fit line. Okay. Relations is a pairing of two sets of information. This stuff right here actually goes on the next page as your example one. I just put it in the wrong place. If a vertical line can be drawn that passes through more than one point on a graph of a relation, then the relationship is not a function. Well, if you go to example one, and those lines should have been there, different relations are graphed below. Which of these are functions? Well, okay, going back to this. A here. Can you make vertical lines go up, right? So is there any point in which we go up that we will ever cross this line twice? And that'd be no. So this one is a function. A function. The reason it is a function is because of the fact that it passes a vertical line test. The vertical line test says there can be no more than one point that is on that same line. Okay, so there cannot be the line that goes up vertically cannot hit more than 1 point on this line. Okay, this one, if we go through this, it's going to get close right here because you're coming into a U, but it's still going to gradually get bigger and bigger and bigger. So this one, there's never going to be more than 1 point that a line crosses going vertically. So it is a function also. C here, if I go right through, use the vertical line test and use where x is equal to 0, it would go through once, twice, 3 times. So that is not a function. So basically all you're doing is looking up and down wise if these would cross. Now this one, like I said, is a little tricky because it is a parabola. So yeah, you're not going to necessarily get that to cross. Okay, so that was actually example one. I put that in the wrong spot, and I didn't feel like wasting any more paper or my time because I already tried to fix it once. Okay, now here it says sketch a circle. Try to get this up and over as much as I can. Okay, example 2 says sketch a circle on the coordinate plane with the center on the origin and a radius of 5. Well, if that's the case, let's draw something like this. Hopefully you guys do a better job than I'm doing right now. 1, 2, 3, 4, 5. So that's a radius of 5 that way. 1, 2, 3, 4, 5. So that'd be a radius of 5 that way. And this way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Draw a circle. Okay, so there's your circle. Now, it says the circle is a relation. List the 4 pairs in the 4 points list the 4 pairs of the points in the relation. Is this a function? Well, you have 5, 0. That would be this one. Okay. You have 0, 5, which would be this point. You have negative 5, 0. And you have zero, negative 5. Is the relationship a function? Well, is there any 2 point, or will we get 2 points if we do a vertical line test here? If you're saying yes, I think you're on the right track. Vertical line test, it's going to hit twice here, here, here. So this is not a function. Because if you use a vertical line test, you're going to go through the circle at least twice each time you go through it, unless you hit right here on the end of the point. But as a whole, this is not going to be a function. Okay. Okay, then we got number 3. Near the beginning of the year, we saw that Preston gathered data on the number of students at the school and the time he arrived. Look again at the graph where he plotted the data, because the entire set of data can be conveyed as a distinct points on the graph. This is the same as a scatter plot. To sketch a graph of the function, a graph of the function that models the data, draw a line of best fit on the scatter plot. Now you can use the best fit line, sometimes called the trend line, to make predictions about the data set. Okay. Trying to remember when we did this. So if you go back in your book, and I never really did this because we never talked about, or I didn't talk about it a whole lot, and I didn't look at this. So if you go look at your book and you look at the plots they are showing, which I can maybe get you here. Okay, you're looking at below are the different ways to describe the same relation, the corresponding between the number of tickets purchased and the price. So the one we're looking at though right now is consider the number of minutes that Preston arrives before school and after school. Okay. So you're looking at this graph. A line of best fit usually goes through or tries to go through, so you'd have something that goes right through all these. Okay. So obviously it told you to draw the scatter plot, what you're gonna get. 10 minutes before school, Preston might exactly see 23 kids in school. Well, you'd go over to your graph, and maybe actually if I do look at it this way, I'll pull this out and I'll leave that scatter plot up here. So you would have created this scatter plot or looked at the scatter plot. Your line of best fit would go right about through here. He's looking at about 10 minutes, which would be right about here. So he says about 23. I wouldn't say he's too far off there. Or according to the graph, might see about 20. I would say you're here. You're just a little bit right around 23, 24 students for part A. How many students might Preston expect to see 8 minutes before school starts? Well, you're looking at 8 minutes. You know, your line of best fit's probably going to come through right about here. You'd be just about 30, but I don't think you quite would be. So I'd go with like 29, 28. Sorry about that, I didn't realize that. Going back to that though, 8 8 minutes before school starts, oh, they go a little bit more. They go, Preston might see 33 students. I was a little off. 8 minutes up. There you go. This does a very good job of diagramming it to help you out. We don't do any practice today, so A, B, C, D. Ooh, that'd be too easy though. I don't think we're gonna go that nice on you guys again. 8. We're on 9, 8. Let's see. I think we are gonna change your homework a little bit. I don't want you guys doing that much. I'll make it a little shorter. We'll go 2 through 18 evens. So that's going to be your new homework assignment on this one. 2 through 8 evens. Okay?